Angie's Corner, we're going to look at linear relations and functions. The first definition that we have is what we're talking about is linear relations. Well, we know linear means line, so it's a relation with a line graph. Nonlinear is the opposite, relations that are not in a line. Now, when we're talking about linear equations is lines. We're talking about lines. So I have no operations other than they can have addition, subtraction, multiplication. We cannot have division in the linear equations. We also know that variables cannot be multiplied together. Variables can only have an exponent of 1. So we have some examples here. Linear equations. So these are ones that work. If I were to graph these, they would look like a line. Right here, y equals 4 over 5x minus 2. That one's in slope-intercept form. Now we have x equals 7. That would be a vertical line. Anything x equal to a number is vertical line. Y equals the opposite there. That's a horizontal line. This 3x plus 5y is equal to 7. Although it's not in slope-intercept form, we could put that in slope-intercept form and graph it, so we're okay. Same thing here. Y equals 5x. That actually is in slope-intercept form. It just is missing that plus in a number. Well, in this case, it's plus 0, right? So the y-intercept is at origin, and then my slope is 5 over 1. Now, equations that are nonlinear, that wouldn't look like a line if we were graph it. This right here, right? This one has division, so we know that it's not a line, right? We set up here that I can't have division. Also, this one is to the second power. Y squared is equal to 6x plus 3. I could graph that, but it's not a line. Same thing here. Multiplied together, x, y. Two variables are multiplied, not going to be a line. And the last one, we have the square root of x. Remember that x, that really is x to the 1/2 power. So again, it's not the first power. So that would not be a line. All right, so let's take a look. The question is it linear? So we have to decide yes or no. Well, this right here is a fraction, which we're allowed to have. So I could put that in slope-intercept form. So that's a yes. Yes, that's a function. Number 2, I have 5x, and then I've raised the power of x to the third. So I know I can't have that. So no, that's not a function. Now let's look at our real-world example here. We have the growth rate of a sample of Bermuda grass is given by the function f of x is equal to 5.9x plus 3.25, where f of x is the total height in inches, x days after initial measurement. So we know x is the number of days. So what is the height of the grass when it's originally measured? Well, when it's originally measured, we know that it's x days. So x is equal to 0. No time has gone by. So that would be f of 0 is equal to 5.9 times 0 plus 3.25. So when I do that, 3.25 inches is what it started at. So that's when it's originally measured. And part B, how tall is the sample after 3 days? Well, f of 3, when x is 3, is equal to 5.9 times 3 plus 3.25. When we do that computation, we have f of 3 is equal to 20.95, and again, that's inches. So after 3 days, that's how tall it is. Compare the initial height versus the height after 3 days. Now, you see this comparison a lot in standardized tests. They love to do this. It's not asking me to subtract. It's asking some sort of ratio, like what happened? Did it double? Did it triple? Or how much did it? So I'm going to take what it is after. It's the tallest there. Divide that by 3.25, and we get approximately 6.4. So I can say the height after 3 days is about 6.4 times the initial height. Now we're switching gears a little bit. We're going to move on to standard form. We use standard form a lot in math. Here it is, ax plus by is equal to c. So an example here, this is in standard form. In this case, a is equal to 3, b is equal to 5, and c, our constant, is equal to 12. Now, we can't graph in standard form. I like to say standard form just kind of, it helps us work with equations in a lot of different ways. We use this when we do elimination method, when we have linear systems. So it is an important one, but we just can't graph with it in this form. So a couple things, no fractions and no decimals. That's really the big thing with standard form that students get confused about or forget about. That's definitely a rule. If I see a fraction or decimal in standard form, I know that you really don't understand the concept of standard form. The a value is usually seen as positive. Now, it could be negative if the other two numbers there are coefficient for y and are constant, if they're also the opposite value, but with a, we usually see as being positive. All right, let's take a look. We're going to write this in standard form. So remember, I want a and b on one side, which is, in this case, we need the coefficients to x and y on one side and our number by itself or constant on the other side. So I'm going to add 14x in this problem to each side, and I have 14x minus 2y is equal to 11. Now, we started off pretty easy, right? My a value here is 14. So we're all set. That's my final answer. I did not really have to do a lot with that one. Now, in number 2, I have negative 3 over 10x is equal to 8y minus 15. Now, I know that I'm not supposed to have a fraction. So my first thing is, well, what can I do to get rid of that fraction? Well, that denominator 10, that's an issue. So I'm going to multiply that by 10, and I get negative 3x is equal to 80y minus 150. And I have to go from there. Now, the easiest thing is to bring this 80y to the other side. So I have negative 3x minus 80y is equal to negative 150. But remember our a value, our number in front of our coefficient, we want that to be positive. So an easy way to fix that is just multiply everything by negative 1. So I have 3x plus 80y is equal to positive 150. So I'm all set. That one is in standard form. Now for the next problem, this is supposed to be 0.12. So I have 0.12x minus 0.1y is equal to 5. Now I don't have a fraction, but the same thing. We can't have decimals, the same thing. So if I look at this, I have 2 places after that decimal. So I can get rid of those decimals. Over here only has 1 by multiplying everything by 100. That will get rid of those decimals for me. So I end up with 12x minus 10y is equal to 500. Now I take a look. It is in standard form. I have x and y on one side. And my a value 12 is positive. So I'm all set. There's my final answer right there. Now, looking at our last concept for today, we're going to use intercepts to graph. So first I have to find the x and the y intercept, and then I'm going to graph those equations. So let's first start with my x-intercept. Now remember, if I look at the graph, for example, my x-intercept would be somewhere along here. Anything along my x-axis is my x-intercept. Well, those points have a y value of 0. So all I have to do is make my y equal to 0. So this is going to be where y is equal to 0. So anywhere I see a y, I'm going to substitute a 0. So I have negative 2x is equal to 4. So x is equal to negative 2. So my x-intercept is going to be negative 2, 0. Negative 2, 0 is going to be right here. And I'll do the same thing with my y value. Let's do that in blue. So my y-intercept, which I'm trying to find now, is where x is equal to 0. So I'll go back to my original equation. Everywhere I see a 0, an x, I'm going to put a 0. Plus y is equal to 4. So y is equal to 4. So 0, 4 is going to be my y-intercept. So there's my 4 there. Now from here, I just have to graph it. So here's my line right here. And I'm going to put arrows on the end because I know lines are continuous. And I'm all set for that one. I graph that using intercepts. I could use slope intercept form, but we'll do that later. Just another way to graph some lines. We have one more example. I'm going to do the same thing. So I have my x-intercept is where y is equal to 0. So I have 2x. I don't know what happened there. Let's take that back. So I have 2x minus 3 times 0 plus 8 is equal to 0. So I get 2x plus 8 is equal to 0. So 2x is equal to negative 8. X is equal to negative 4. So my x-intercept there is going to be negative 4, 0, which I know is right here. I'll do the same thing. And my y-intercept is where x is equal to 0. So I have 2 times 0 minus 3y plus 8 is equal to 0. So I have negative 3y is equal to negative 8. So y is equal to 8 over 3. So I have 0 and then 8 over 3. That's my y-intercept. So I have to approximate here. This is approximately, we have, what's that, 2 2/3, so just about at 3. So I'm going to go a little bit underneath, and I'm approximating on that one. Draw my line, arrows on the end, and I'm all set. That's the lesson for today.